Okay, so let's start with electrolysis. That is our fourth unit. In the previous unit, we discussed about the different types of chemical reactions. We talked about the different equations that you can write. So you can write chemical reactions as word equations. We can write chemical equations, and we can also write the chemical equations as ionic equations if ions are participating in the chemical reaction. And we can break those ionic equations down into the ionic half equations. Okay. So, Maham, you were present in that lecture. So, can you tell me what is an ionic half equation?
Is it when you cancel out the um the substance which is the same on both sides?
Exactly. Okay. And what is that called? And what is that substance called? What are those ions called? Those are known as spectator ions. Okay.
Respect. Yeah.
Yes, exactly. Very good. So, जो uh, when we cancel out the spectator ions, so what we're left with is the net ionic equation, right? And when you break that ionic equation down, when you break that net ionic equation down into the reduction half and the oxidation half, so what you get is the ionic half equations, right? And in ionic half equations, you'll see electrons. So either there's a loss of electrons if it's an oxidation reaction, or there is a gain of electrons if there is a reduction reaction. So electrolysis involves the key core concept at its very core. It involves the concept of redox, right? So the whole electrolysis, you'll only understand if your base of redox is like really good. So let's start with the lecture. So if you talk about electrolysis, so electrolysis is basically the breakdown of a chemical compound using electrical energy, right? In very simple terms, it is just the breakdown of a chemical compound using electrical energy, right? So in earlier in bonding, we learned about the bonds, right? Different types of bonds. We learned about ionic bonds, covalent bonds, metallic bonds. We learned about the coordinate covalent bonds, right? So जो bonds होते हैं ठीक है they're really strong, right? And in order to break those bonds you need to put in some energy, right? So for example, if you have a really strong wall, right, you need to break the wall, so you need to hammer it down, right? You need to put in the energy. So and that's where the electrical energy kicks in, right? So we can use the battery, we can use the energy from a battery to separate those chemical compounds, to break them down into its individual constituent elements. And that is the core concept of electrolysis. So electrolysis is only applicable on compounds which can conduct electricity, right? So in order to conduct electricity, what you should have free charge, right? You should have mobile charge. So solutions which contain mobile charges, like your charged particles, uh, are ionic solutions, right? Because if you dissolve an ionic compound in an aqueous in water in a solvent, so if you dissolve an ionic compound in a solvent, so the ionic compound will dissociate into its constituent ions, right? So, for example, if you have a simple glass of water, okay, and let's just color the water blue. So we have a simple glass of water, right, and it contains pure water. Okay, it contains distilled water. So distilled water, if you talk about distilled water contains absolutely no impurities. Okay, it has a pH of exactly 7. Okay, so it has a neutral pH and it only contains water molecules. Okay, so in ideal case scenarios, it does not contain any impurities, any minerals, or any ions, right? So distilled water is is it a covalent compound or is it an ionic compound? Maham.
Covalent.
It's a covalent compound. Can it conduct electricity?
No,
No, exactly. Okay, very good. Why doesn't it conduct electricity?
because it doesn't have a free electron.
Yes. Okay. Very good. Excellent. So distilled water, very pure water, does not contain any electrons, any mobile charges, and that's why it's not able to conduct electricity, right? So normally, when you're referring to water, you're referring to tap water, okay, or you're referring to the water that you drink, right, in every day. What you use for washing your dishes or what you use for bathing is not pure water, right? And that water can conduct electricity. The reason is that that water is not pure water. So it contains many, many dissolved impurities, right, in the form of ions, minerals, etc. Okay. So that water can conduct electricity. So if you were to submerge your hand in that water, and if that water has like some live wire inside, so you will be getting electrocuted, right? So don't even try that. But in distilled water, it's really safe because it does not conduct electricity at all. Now, what happens is, what will happen if I just, submerge? What will happen if I just, dissolve some salt in this water? What will happen? So if I put some salt, okay, if I put a teaspoon of sodium chloride, the table salt in this water, so what will happen is that, and I just whirl it around, I just mix it up. So what will happen is that sodium chloride, solid sodium chloride, right, will turn into its aqueous form, right? And by aqueous, I mean that it will dissociate into its ions. So we have, we'll get what? We'll get sodium ion, and we'll also get the chloride ion, right? So we'll get two ions, sodium and chloride. Now this now this sample of water can conduct electricity because it has free ions, right? So which type of compound can conduct electric current and why? And why can these substances conduct a current only when they are dissolved in solution? So let's move on. Again, let's see, okay, why is that the case? So these can't conduct electricity because they don't have the free charge, right? And when you dissolve sodium chloride in water, so it dissociates into ions. So we have a chloride ion and we have a sodium ion, right? And those are charged particles and they can obviously conduct electricity. So let's talk about more about the ions. Cations. What are cations? Cations are positively charged ions. Okay. Acha, Azlan, do metal atoms form cations or non-metals?
Metals.
Yes, metals, because they lose electrons, right? They have less electrons in the outermost orbitals. In order to get stable, they will lose that electron and they'll form a positive ion. Anions, on the other hand, vice versa, they are negatively charged ions, and normally it's the non-metals that form the it's the non-metals that form the negatively charged ions or the anions, right? So in case of sodium chloride, sodium will form the cation, and chlorine, on the other hand, will be the anion, okay? The negatively charged ion. So remember, cations are positively charged and anions are negatively charged, okay? So ये होता है difference between cations and anions and the types of elements that will form cations and anions. Now, ionic compounds conduct an electric current because they are made up of charged particles, and that's why they can be electrolyzed, right? And these substances conduct a current only when they are dissolved because the ions are able to move freely in a solution, right? So if you'll have to actually dissolve the table salt in water for sodium chloride to actually conduct electric current and for the process of electrolysis to start. Okay, so the process of electrolysis. So let's see. So let's just learn about how electrolysis actually occurs and what are the components which are required for electrolysis to occur. Now, we did go over this briefly yesterday, but I'll just repeat it because Maham did not join. So, electrolysis occurs in a cell that is called as an electrochemical cell. And what are the components of electrochemical cell, Rafi? Oh, sorry, Aslan. What are the components of an electrochemical cell? generally. It's सामने बना हुआ है. So
Like
हाँ,
an electrode.
can you speak a little bit louder?
It has an electrodes.
Yes, it has electrodes, and those electrodes are connected to
Electricity?
electricity, yes, or in other words, it's connected to a battery, right? So the electrochemical cell has electrodes and is connected to a battery. Now, these are two electrodes, okay? And now when you connect them to a battery, so they will become cathodes and anodes, right? But which is which? So let's talk about that. So right now we are just discussing okay, what is an electrochemical cell and what it's made of. Okay. So if you want to electrolyze any compound, so you need to do it in an electrochemical cell. So an electrochemical cell is consisting of a battery. Okay. Positively charged terminal hota hai, and we have a negatively charged terminal of the battery. Right. When you connect this electrode, this let's just color it, let's just use a different color for this electrode. So if you connect the green electrode to the positive terminal, so this electrode becomes positive, okay, right? And this electrode जो है, it will become positive. So yeah, and this electrode right here, let's just color it red. So this electrode will become negative, okay? So the positive electrode and the negative electrode. Now these electrodes will have names now, okay? So let's just use a different color. So this will become a negatively charged electrode. The positively charged electrode, what is it called? Aslan, what is the positively charged electrode called? I cannot hear you. You could come again.
I don't know.
Okay, okay. The positively charged electrode, it's called the anode. Okay, anode. And I'll tell you why it's called the anode, right? The negatively charged electrode, on the other hand, is called as the cathode, right? Now, why are they known as anode and cathode? We'll talk about that. So this is like the basic framework of an electrochemical cell. Now, if you just submerge this whole unit in a container, okay, let's just draw a container, okay, and this container is, for example, is filled with a very conductive solution, okay. So we just fill this container up with a very conductive solution. Okay, let's just use a different color for this conductive solution because this doesn't look really nice. So if we fill up this container with a really conductive solution, okay, let's just say we have the sodium chloride solution, okay, our trusty old favorite sodium chloride solution. So we fill this up with sodium chloride solution or brine solution, right? So when we submerge this, this whole apparatus into this container, this makes an electrochemical cell. So, yeah. And you see that as a chemical reaction starts to occur, okay, as soon as you submerge the electrodes into the solution. So this is so that my students, that is actually the electrolysis going on, right? So what will happen is in this sodium chloride solution, we have two types of ions. We have sodium ion and we have the chloride ion, right? So the sodium ion, is it the cation or is it the anion? Mom, sodium ion, is it the cation or anion? And what about the chloride? Hello, mom.
Sodium the anion.
No. Sodium, positively charged ions are the cations. Okay, we just talked about it in the previous slide. That the positively charged ions are cations, okay, and negatively charged ions are anions, okay. So anions have an N, okay, and that's why they're negative, right? And cations, they are positive. So yeah, the opposite. Okay, so sodium chloride, where sodium is positively charged. So just tell me, which electrode will it be attracted to? The positive electrode or the negative electrode? Sodium.
The negative.
The negative electrode, exactly. And that's why the negative electrode is called as the cathode, right? Because it attracts cations. Right? It attracts cations, and that's why it's called as the cathode. On the other hand, chloride will be attracted to the positive electrode because it's negatively charged. And that's why the positive electrode is known as the anode. Okay, because it attracts the negative ions. So we'll talk more about electrolysis and its working principle in the next video.